Good morning, good afternoon, whatever to everyone. Happy to be here. I'm Guido Pickert, VP of Investor Relations at aixtron. Been with the company since 2007, so have experienced some ups and downs in the history of the company. But that's not the important thing. I think the important thing is the look ahead. The company exists since 1983, has a worldwide presence. Its headquarters are in Germany, in the region around Aachen, which is in the northwestern part of Germany, right at the border of the Netherlands and Belgium. We have around 1,000 people now, having added a lot of people in the recent years, and yeah, you can tell why if I go into the presentation. Here is the timeline. I told you that we've been founded in 1983, so 40 years of high-tech experience that we've gathered, and we went through different waves of adoption of different technologies. Important to note is that we have deposition systems. So we, for the industry, provide the systems that they can use to deposit certain materials on a wafer, and those materials have different properties. And these materials, as they are, as we talk about combined materials, so-called compound materials, those differ from the industry or the semiconductor industry, which is widely known, namely memory and logic, because the compound material industry is different than the traditional silicon semiconductor industry. So that's important to note, because we are underlying different drivers of demand. So important, we are only in the area of deposition. We don't make wafers, we don't make chips. What are the properties? What are the areas or the markets that we address? It can be divided into two groups. The right part is the so-called optoelectronics. Here you have materials that have properties that either emit light or absorb light and turn them into power. On the other side, it's power management. So everywhere where you need to change voltages from low to high, from high to low, or where you need to change current from AC to DC or the other way around, this is where you need power electronics. The majority of those are based on the material silicon, and more than 90% silicon based. And those new materials that our customers are producing on our tools, namely gallium nitride as a combination or silicon carbide as a combination, are set to replace silicon in more and more applications in the area of power electronics, because they are more efficient, meaning while switching, they have less losses, generate less heat, so can be either made more compact or are more efficient in a way that you save energy while doing the same task. This is very important and very, very big drivers for the demand of our customers that make the respective chips. So going into some details, here we have silicon carbide. Why is silicon carbide set to replace silicon? Because, as I said, less switching losses. And if you think about the biggest driver of demand for the moment, which is the electric vehicle and the fast charging infrastructure, you can imagine if you have a so-called main inverter sitting between the battery and the different motors, it always has to switch back and forth between AC and DC. The battery is DC and the motors are AC, so all the time back and forth. And if you reduce the losses while switching this dramatically, this will definitely result either in a smaller battery doing the same, getting the same range, or in a much higher range. And this is exactly what the industry wants to provide to us as customers. Electric vehicles which usability is increased through higher range. And this is why silicon carbide is making huge inroads into the markets right now. And we will see more and more new electric vehicles coming to market with silicon carbide on board, as well as we will see more and more of this fast charging infrastructure coming up. So silicon carbide is at the beginning of its broad adoption in the market. As I said, more than 90% still silicon based, and round about 6% of the market is currently silicon carbide based. So it's a very low number, and that this is what fuels our optimism going forward, that the industry is building dedicated fabs with silicon carbide for silicon carbide chip production involving our tools. And we see this kind of demand going up significantly for us. The other material that I talked about is gallium nitride. And here, in contrast to silicon carbide, which covers, let's say, medium to high voltage range applications, in gallium nitride, it's the lower voltage applications. So everything up to maybe 800 volts will be using gallium nitride, same logic, less switching losses, again, resulting in a higher energy efficiency. And either just to paint a picture of that, either you can make, for example, things like chargers much more compact because of less heat, less cooling requirements, and more efficiency. And those things charge your phone, your laptop just much faster. So what we all know as a laptop charger, these big blocks with a big thick cables on them, you can really massively reduce the size of those, making them really compact and nice and carryable, replacing these big silicon-based chargers. So this is one thing, and the biggest driver at the moment is coming from the industrial applications. It's the power supplies. So if you have a certain power requirement of, let's say, a base station around the corner, or an air conditioning system that runs constantly, or in the currently biggest use case in the area of IT infrastructure, namely servers or the data centers themselves. So you have a certain requirement of power supply, and you can again dramatically reduce the energy required to provide this power by using more efficient materials such as gallium nitride. So this is the target of customers like Texas Instruments, for example, really going into that market, providing power supplies for data centers, for hyperscalers. It's becoming even more important going forward. And then the industry is already moving on, looking for the next areas or pockets of the market in which they can replace silicon with gallium nitride, or in the other part with silicon carbide. So very, very strong dynamics in the market, not driven by, let's say, the hope to be in the next smartphone model. It's really driven by overarching schemes of energy efficiency or electrification. Now, since power electronics is only one part of the markets we're addressing, we're also active in the area of optoelectronics, which is something that I show you here. Actually, I'm coming to the bonus or the optionality which we have in this market right now. It's called micro LEDs. You know, everybody knows LEDs all over the place. We also know the big advertisement displays all over the outdoor displays. And now imagine this to be shrunk in a way that you can use it as a TV, or you can use it as a display on your smartwatch, your smartphone, etc., or in your car, wherever. So really making the LEDs so tiny that they can serve as individual pixels on a display that is very close to us. That is a big challenge. On one side, when you produce the wafers on which these LED structures are being deposited, they have to be at the highest possible quality. That box is ticked. This means our tools are already fulfilling the very, very high quality expectations. But now comes the challenge. Now you have them, first you have them on the wafer, you need to get them to the display. So what they do is they cut them, they structure them as if they were already these tiny little pixels, and now try to transport these LEDs from the wafer physically to the display. And this kind of mass transfer is obviously still a challenge when it comes to high volume manufacturing. It's possible in the lab. You can buy a TV already today, probably having to spend 100,000. Not quite my budget, but well, that's possible, but it's not yet, I would say, Best Buy capable. Yeah? So going into high volumes. We are helping the industry on that path with our tools, with the productivity, with the multi-wafer output. But as I said, the challenge of the steps that follow our step are not yet fully met. So we have shipped first production volumes into a fab of a customer of ours that is actually a supplier into one major consumer electronics giant that intended to come up with a watch of theirs with a micro LED display. Because of the challenges that have not yet been fully met, they have, let's say, pushed out the introduction to what the market believes 2026. So that is currently a little bit on hold. We have shipped the systems, that's okay, but they're not yet utilized. And second thing is, we are not yet seeing tangible evidence of somebody else lining up to become ready to move into volume manufacturing. So there is a lot of noise in the market, and some do even claim they have managed to get the mass transfer done, but we'll wait and see. So for us, this can be a huge opportunity. Just thinking about high volume products like a smartphone, that could mean hundreds of tools required at a ticket price of around about 3.5 million. So a huge opportunity for us, coming closer and closer, but being not yet here yet at this stage. The parts of the optoelectronics markets that are here, first of all, lasers. So two types of lasers. On the left side, you see the glass fiber networks, and this light that is being transmitted via glass fibers. This light is being generated by lasers made on our tools. So our customers are using our tools, producing the lasers, and then getting them into the networking. So that means either the long haul networks, so the ocean cables being provided with those lasers, the fiber to the home connections for fast internet, but it all goes further and further into the IT infrastructure, so going even between servers, between computers themselves. So it all goes optical. What you see also on that picture are the traditional copper cables. They will be fully replaced by glass fiber, by optical datacom over the next years. And this also fuels our optimism in this space that demand will continue in a double-digit million contribution per year. But this also means demand from what you see on the right side, other types of lasers used for so-called 3D sensing. 3D sensing is scanning an object in its three-dimensional aspect. And the most famous, I would say, application for that is Face ID of Apple. They use a laser made on our tools to scan your face and open your phone. So this has caused some strong demand in building up the capacity for that application, but it never made it outside of Apple. So there's something here, something there, but nothing really huge. That could change over time when the functionality called LiDAR makes inroads into the broad adoption into the market. LiDAR means laser detecting of its surrounding of a car or of a driving object. So this kind of functionality could cause stronger demand in opto, especially for 3D sensing lasers. In total, as I said, the optoelectronics business should contribute on a double-digit million range somehow towards the upper end over time, driven by these two applications. So the tools we make, we have now three different platforms out in the market that are defined. The differences are defined by the material systems. On the left side, the G10 SiC, silicon carbide, very much optimized for high volume manufacturing on either 6 or 8-inch substrates. That's important to note because the industry is moving from producing the structures on a so-called 6-inch wafer, the wafer with a diameter of 150 millimeters. This is going to 200 millimeters. But the wafers are not yet available, so the industry takes another 1 to 2 years, but our tool can do both. That was the clear target. The other part in the middle, the tool in the middle is the G10 GaN tool, very much adopted to the demand or the requirements of very, very highly automated fabs that are being built with automated wafer distribution, wafer manufacturing, wafer transport, everything really on the highest standards. So this is our latest family member that joined the G10 family. And on the right side, you see the tool to be used for the lasers for the red, for the fiber lasers or the 3D sensing lasers, the G10 ASP. So a whole new tool generation out in the market, and it's being very well adopted by our customers. So they love the productivity enhancement and the way the tools are designed. Revenue-wise, for us, you can see over the years we've been around 200 million revenues, then around 250, made the step up to 450, now made the step up to 600, 630 in the midpoint. And the next step could be when micro LED really comes into the volume adoption. Until then, we see growth fueled by the adoption of silicon carbide and gallium nitride, the power management area, and this keeps us at these high levels of, as I said, at least 600 million. And the next step change could come when micro LED moves into broad adoption, I would say. Quick one on Q3. No, the quarterly development on orders and revenues is not very even. It's evenly distributed throughout the year. We've seen a somehow lower order intake in Q3, as well as lower revenues. This is the order intake is much linked to customers' planning, to also the stage of the negotiations of orders that we had. And we have repeatedly said we reiterate our full year guidance, which means this lower order intake will be at least made up in the fourth quarter to get to the guidance. So this is we are very confident on that because of knowing that the contracts are coming in, are being finalized. And on the revenue point of view, the revenues were lower, partially also because customers had some issues with their fabs and asked for some delays. No problem for us. We've done that, and they will be shipped in Q4. And the broad range we kept, especially in revenues, is clearly linked to the fact that we require what's called export licenses to ship our tools into many countries. And those export licenses are being distributed by the German government, and they have been very slow in processing these applications. And this is why we are not quite sure how many of those applications that are in the pipeline will actually come out of the pipeline by December, let's say 25 or something like that. So this is what we're waiting for, but it's looking good. We clearly are on the path of the guidance. The question is where we will end up. That depends a lot on these licenses. So the guidance that I mentioned here again, total order intake 620 to 700, revenues 6 to 660, and then depending on the volume, the EBIT margin 25 to 27, and around the 45% gross margin. So quite decent numbers that we're approaching here. And as I said, it depends a little bit on external factors where in the range we will end up. Just a little word on ESG. We have very strong figures in the area of EU taxonomy. It's important to say that those figures are aligned numbers. They're not eligible numbers, they're aligned numbers. This is very important because it's already proven that our technologies have a positive impact on energy consumption and other things. So that is why we can state our numbers as aligned figures, very high, as I said, and combined with good ratings in the ESG rating world. So overall, I think we're on a good path here. Yeah, and now I would open the floor for questions if you want.
Okay, Guido, thank you very much for this excellent presentation. I think that was not only interesting, but we are touching something that we did not touch yet in the IIF in their specific sector. So this is always interesting for investors to look at new ideas and new companies. So we do have a few questions. Thank you very much for the Q&A. And then what we will do also is, please, if you have more questions, don't again hesitate. So first off, with 44% of revenue, so this is a question from Adam, with 44% of revenues for the first 9 months of 2023 being Asia, Could you give a rough indication of China's share of these revenues?
Sure, happy to. China is without going into exact details, but is below 30%. So 20 to 30%. That's what we've seen. What we've seen the range is, or the area of share of demand from China.
Perfect. Also, how do you think about key competitors in the silicon carbonate MOCVD, for systems that can accommodate 200 millimeters? Are we seeing anything yet that can rival the G10 SiC in terms of thickness and doping uniformity requirements?
Yes, very good question. You have just to zoom out a little bit, you have two different approaches or architectures of tools. One is the one that we have, the so-called multi-wafer approach, meaning you process multiple number of wafers in one process run, whereas the others are offering so-called single wafer architectures, and you process one wafer in the single run, which means you have let's say a better control over the single wafer and the uniformity on it. We've made huge steps forward in our development, that we now reached at least par, if not even better values on the uniformity throughout all wafers that we address in our multi-wafer environment, be it on 6-inch or be it on 8-inch. So we feel very competitive in this space, having made these kind of advances. So customers are testing our tools now and looking at the repeatability of those fantastic results. And this is work in progress. Others have in the meantime decided for our tools already. So it's not only members of the known group of top 5 device makers like Wolfspeed, onsemi, Raum, Infineon, and STMicro. It's a lot of customers outside of that field, Bosch, for example, or others that are entering the market, partially very large. So our optimism is not only based on trying to convert players that have an installed base by Tokyo Electron. In this case, it's also because we win new customers with a proposition that we have with our tool.
Well, this is a great answer. Obviously, Adam, thank you very much for your question. Marcus is also asking basically 2 questions. First of all, there is discussions in different internet boards on whether aixtron SiC epitaxy tools are installed in Wolfspeed Mohawk Valley fab. Can you please clarify?
That's a very clear answer I can give. No, we're not in Mohawk Valley. Wolfspeed is building a number of fabs. Mohawk Valley is their wafer processing fab. So wafers that have been used on our tool are then processed and made into chips at Mohawk Valley. We are in either Durham, which is the headquarters of Wolfspeed, or Siler City, which is the newer fabs they built for the making of the or deposition on the wafer. So the problems they have in ramping the Mohawk Valley fab are clearly not referring to our tools or to our step that we address.
Perfect. Michael is asking a very interesting question here. In order to calculate the taxonomy, it is also necessary to know in which applications the product are used. Are customers always willing to disclose this?
Yes, they are. I mean, just clear, if you look at TSMC, they are not telling us, okay, this part of the utilization of the tool goes into this application or that, but the end applications that all of our customers are addressing are very clear. It's the power electronics market on one side, be it the chargers, be it the power supplies, whatever, and then it's in silicon carbide, it's the automotive, it's the industrial renewables, etc. So the overall end markets that are addressed by different types of customers, but on our tools are very clear. And even I don't know whether you knew this, the optical data communication through glass fiber is much more energy efficient than if you used copper cables. Yeah? So that's another aspect of the move into optical datacom. It's not only the volume and the speed of data transmission, it's the energy efficiency at the very end.
Yeah, let's not talk too much about replacing copper, as we have mining companies this afternoon on copper. They're not going to be happy
Okay,
to hear you
sorry.
saying that. But absolutely,
Sorry.
I agree with you, no doubt about that. Lisa is asking, is the business dependent from economical cycles?
Less than, for example, in consumer electronics purely or in other markets. So what I said at the beginning, that energy efficiency is driving demand, or the move into electrification of transport, for example, this is somehow not directly linked to the economy. It's maybe even promoted by that. If you can save energy, you save cost. And why then invest into something that's less energy efficient? So we see a very strong pull. And even if customers talk about capex reductions, they are not referring to the compound semiconductor space, because they see clearly the markets pulling, and therefore a certain independence of the economical environment.
Okay, perfect. And then the last question, surely we'll have time for, is again from Marcus. So thank you, Marcus, for the interaction. We're going back to the Wolfspeed question here. And are your equipment, so is the aixtron epitaxy equipment will be installed in the planned Wolfspeed Ensfeld Saarland?
With ZF together? No, I'm not sure. I'm not sure what they plan here, whether they want to do the chips only, or they even want to do the deposition on the wafers. I'm not sure. It could be that the wafers continue to be made in the US and then shipped over there and then made into chips. This is, I'm not sure about. Yeah, that Wolfspeed can certainly answer that to a stronger degree.
Well, we have about 20 other questions, but Guido, this is 10:30 already, so it is time to let you go. First of all, thank you for the great presentation. Obviously, absolutely a company to keep on following if you guys were not following it before. So Guido, I thank you very, very much for your time. We wish you the best of luck, obviously, with your new product. We hope that the micro LEDs will be adopted very, very soon, and so that give you a big boom in your business for sure, which
looks quite well. Looks quite good.
Perfect. So thank you very much once again.
Thank you. All the best to everyone. Bye. Thank you.